were the importance of a flat floor for the planter to plant into, but what are the things that gives that flat floor when you use in a field cultivator? All right, what we have here for an example is the Case IH Tiger Mate shank assembly and the John Deere shank assembly. We have here the John Deere 200-pound shank assembly. Ours we call the 150-pound shank assembly. Now, that pounds of pressure is immaterial because every company has their own way of logging it. Well, we're going to talk about equal pull to see how they fit side by side. To give some credibility, we need to establish the tip is 1.25 inches compared to 1.25 inches. So our tip to tip, John Deere and Case IH, is the same. Now let's look at something else. The wing, the tip of the wing is 3/4 inch high compared to a 0 on the tip. All right, a 0 on the tip for Case IH, and the wing is 7/16 of an inch. See, we have less tip to wing variance, gives a flatter floor. Now you think that's insignificant, but it's dramatic for the planter because you want every seed at the same depth for every row unit. All right, the next thing we want to look at is just the shank assemblies. I have to compliment Deere for cost because they keep a formed out assembly, a spring, a casting, and the shank. It's kept that cost low, and it's a thicker shank than we have. All right, now with the Case IH, we have the spring, we have this formed channel around the shank. By the way, you know why we use a formed channel around the shank? If a shank breaks, it's usually 8 inches behind the fastening point. And what we do is we protect that shank and do it in a way that you don't have a pinch point on the rear. Pause. The primary reason we have outstanding shank and shank assembly life. We've earned that through the years. All right, but the next thing we want to look for is as we pull the pressure back, and on the assembly we have a hydraulic pump, and we have the cylinders wide together so it's equal pressure, and we're going to pump the pressure up and watch how the shanks come back, and we'll see how they vary, or if they even vary, on the yielding of pressure. Tighten the valve, and I'll pump this up. And we begin to pull back. Pause. As we pull this back, and right now we're at 200 pounds. That's doubled, so it's 200 pounds. And as you look, how far back has each of those come from the starting point at 200 pounds of pressure? So irregardless of what we call in our manual shank holding power. Let's put a little more on it. See how we're pretty universal on coming back? Now we're sitting at near 300 pounds of pressure. Let's just examine. We have come back 1 inch and 7/16. We have come back 1 inch and 9/16. It looks like the Case IH has held more pressure than the John Deere. But let's look at something else here. At this 300 pounds of pressure, now our tip was pretty flat, and our wing has raised to 3/4 inch. Went from 7/16 to 3/4. Deere went from 3/4 inch to 1 3/8. Look what happened to the nose, also went down. Now let's look at what happens when that takes place. Our shank yields along with the spring, and it maintains a sweep at a flatter floor. Now John Deere's shank is thicker, and if you watched it work, and we can repump it to show you, when the spring yields but the shank doesn't, therefore the tip goes down and the wing comes up, and that's what separates us, wing to tip relationship. And that's why we get the flatter floor and will complement any planter for uniform emergence, and emergence is king. Anything we do to get uniform emergence, we must be looking at in our cornfields. Let me release the pressure, and then we'll pump it up again, but this time we want to focus on how the spring and the shanks relate to one another. We're going to tighten the valve again. And as I pump this up, I want you to watch how our shank is giving and Deere's is not. It's all the spring collapsing. Notice that? It's the spring, not the shank on Deere. Ours is shank and spring. There was the 300 pounds. $375. Wow. 2 1/8. 3 9/16. Now, when you would ask your question, if you didn't read the manual to see which one has more holding power, which one would you evaluate has more holding power based on this display? Those are the issues that we really have to look at. These are issues that make us money and give us a return on the investment that we make, because everything has to complement putting the seed in the ground. Pounds of pressure is usually all I'll see. Sometimes you may get a condition on headlands you can see 200 pounds of pressure, but let's crank that up to about 150 pounds, and that's right there. That's what most are going to see. Do you think both of them are doing well? Yes, and we have a flatter floor. Let's pump that up now to the 200 pounds. There's 200 pounds, and you see, we still hold a flatter floor because our shank and our spring goes together. Now we're going to go some extreme here now. We want to hit that 300 pounds. And as we see the 300 pounds, right there, universal pressure, at 300 pounds, it would be an exception to see more pressure than that at today's Corn Belt market. So which flat floor do we have? Anything we hold more than that really doesn't gain us anything in the field and for putting the seed in the ground. About 375. See how the Case IH shank sweep will go flatter back in position where the deer, as the nose comes up, the wings go down. It's giving you a perspective of what happens on the way back. Is it that the Case IH Tiger Mate field cultivator handles more residue than any other assembly in the market? There's a number of things. One, the shank positioning, which we call split the middle shanks. But one of the key ones that we need to address is, I want you to observe the the design of the shank. There's 2 bends or 3 radius points, but as the soil comes back farther before it comes up, it lets it boil higher. That boiling action is what feeds that hairpin residue off that flat shank, and right there is one of the key issues. When you look at deer, it comes back and it doesn't boil as high. The 2 machines running in the same field side by side, depth and speed, you find we boil soil higher. And that boiling soil is what feeds residue through and gives uniform parts per million of the residue. And if you happen to have a chemical incorporating, it'll give you better parts per million of chemical incorporation because of this boiling action. Just observe again the design of the shank so it comes back farther before it comes up. In here, it comes up straight up more abruptly and doesn't boil as high. These are things you can watch for in the field, in your fields. In this view, as you look at the shank assemblies, we have the 2. This is the Case IH Tiger-Mate assembly. This is the John Deere shank assembly. All right, and we've talked about the formed channel to protect this shank to give us outstanding life. But what you want to look for is that shank assemblies or shanks on field cultivators, when they break in an extreme condition, it's usually about 8 inches behind the fastening point. Fastening point being this bolt here, so that would be at this point. You see how we're protected with the formed channel around the shank? Now let's observe the deer. Here's your fastening point, 8 inches behind, and you're right here. So you see we have a pinch point right in this section, about that wide, about 2-inch pinch point, where it's vulnerable to snapping in an extreme condition in rocks. Another reason why you'll find it's true to the Case IH tradition that International Harvester has a field cultivator assembly that lives long but agronomically complements the planter.